Good afternoon, everyone. My name is Saurabh. Today I am going to present KMP algorithm in DAA, Data Analytics and Algorithm. So KMP, it is one of the most efficient algorithm used for string pattern matching. The main goal of KMP is to search for pattern inside a large text without repeating. So let us start our topic. In this slide, what we cover in this presentation, I will explain 6 topics. First, the problem with a narrow approach. Second, the key idea behind KMP. Third, the LPS array. Fourth, the search process. Fifth, Python implementation. And the last one is sixth one, time complexity and real world application. So let us start my first topic, problem with the narrow approach. So let us first understand the problem. Suppose we have the long text and we want to find a small pattern inside it. The narrow algorithm compare each character one by one. A mismatch if a mismatch occurs after server successfully matched, it start again from the next position. This means the same character are compared repeatedly. Because of this repeated comparison, the worst case time complexity become O of n into m, where n is large, where n is text length and m is pattern length. So let us continue from my next slide, that is on the key idea, never look back. The key ideas of KMP. The main idea of KMP is very simple. Instead of starting from the beginning after every mismatch, KMP remember the character that have already matched. It store this information in a simple table called LPS array. Using the LPS array, the algorithm known exactly how far to move the pattern without clicking the same character again. This makes the search much faster because every text character is processed only once. So let us continue from my next slide. In this slide, we will learn about LPS array, building the LPS array. LPS stands for longest prefix, which is also known as suffix. The LPS array tells us how many characters can still be considered matched after the mismatch. For example, let us take one example, ABABC. The first A has LPS which value is 0. At index 2, prefix a is also a suffix, so LPS is 1. Okay, here LPS is 1. At index 3, the prefix AB is also a suffix, so LPS become 2. Let index 4 there is no mismatch prefix and suffix, so the value is 0. This is important point is that this array is created only once before searching start. So let us continue from next slide. In this slide we will learn about the search phase. Now the search begins. Two pointer are used. The first pointer moves through the text. The second pointer moves through the pattern. If character match, both pointer move forward. If mismatch occurs, instead of moving back, the pattern point jumps according to the LPS array. The next pointer never moves backward. This is why KMP is much more efficient than the naive algorithm. So let us continue from next slide. In this slide we will learn about algorithm step by step. So the KMP algorithm has two main phases. First one, build the LPS array. Second one, scan the text. First, build the array from the pattern. And second, the text using the LPS value. Whenever a complete match is found, the position is reported. If mismatch happen, the LPS array tells us where to continue without repeating previous comparison. So the algorithm avoid unnecessary work. Let us continue from next slide. In this slide we will learn about Python implementation. This slide shows the Python code. The function complete LPS method create the LPS array. The function LPS search method format perform the actual pattern search. Whenever the pattern is found, it start index in sorted in text list form. This implementation allow extractly to the two-step process that we discuss about that either. So let us continue from next slide. In this slide we will learn about sample run complexity. Here we can see one example. This is here the text is AB, AB, ABC, A, BA, BC, and this pattern is AB, ABC. The algorithm finds the pattern at index 2. Now let us compare the complexity. The naive array that takes O of n into m. Building the LPS array take O of m. Searching take O of n. So the total complexity of KMP is O of n plus m, which is the most faster than large input. Let us continue from my next slide. In this slide, we will learn about application and conclusion, where KPN is used. KPN mainly use real world example. It is used to text editor for finding the pet replace. It is used to search engine. It is used search engine. It is useful to format the form DNA sequence matching. It is also used in paradigmic decision, network security, and computer design. Compiler, token and keywords recognized during luxury scanning. Let us continue from